Arrays in Visual Basic give us the length property, which tells us what the size of the array is. This is pretty much the same thing as the length field in Java for arrays. Same idea here. So let me give you an example here. So let's say we have the following code. So we're declaring an array of integers. It's called names. And then we pass a 5. So that tells us that the size of the array is going to be 6. But if we want to know the exact number, what we can do is we can use the name of the array, a dot, and then length. So this part right here. This actually gives us the number of items in that array. And we see here that we can store it in an integer. So in this case, we just stored an integer called size. So what we're really doing here is we're going to assign the value 6 into our size, and we can just use that to refer to a number of elements. So in this case, we can use either size or we could use names.length. Either one is perfectly fine. Now, there is another method we can use that corresponds to arrays, and this is called the getUpperBound method. This method simply gives us the last index of the array. Now, granted, we could just get the length and then subtract it by 1, but this is another method that is available, so we might as well take a look at it and see how it can be used. This method does take an integer as a parameter. This parameter corresponds to the dimension number of the array. So right now we're talking about one-dimensional arrays, so we would use 0. If we were dealing with two-dimensional arrays, which we'll talk about later on, we can specify the last index of whichever dimension we want. So 0 would be the first dimension, 1 would be the second dimension, and so forth. But right now, since we're dealing with one-dimensional arrays, we would use a 0 for the argument that we would pass. So let me give you an example to show how we would use this. So here's some code where we are declaring an integer array of names, and we see that the last index is going to be 5. Now, granted, that means we know what getUpperBound is going to give us, but later on in the code, we might want to use the method instead. So we see over here that the way we call this is we would put in the name of the array, dot, and then getUpperBound, and then pass the 0. And this is going to be stored in an integer variable called lastIndex. So what we'll see here is that we would store 5, which is the last index of the array, into the lastIndex variable. Let's do another example where we would traverse through an array. So let's say we have an array called empNames, and we're not worried about how many elements are in the array, not yet at least, and this array would store all the names of the employees. What we can do is use a for loop to add all these employees into a combo box. And for our purposes, we'll call this compemp. This is actually a very common thing to do for business applications where you can have a drop-down menu of all of your employees. Well, if we don't know the number of elements in the array, we can use the getUpperBound method to give us the last index of the array. That way we know where we can start and where we would stop to add all of our elements into this combo box. So let's take a look at the code and see how we would do this. So we create a variable called last. So that's going to represent our last index of the array. And then we see that we have empNames.getUpperBound right here. So that is going to give us the last element of the array, and we store that into last. And then we can use that in our for loop. So we have for I as integer equals 0 to last. So that gives us the last index. And then what we can do is call the add method from compemp.items. So if you don't remember to add an item to the combo box, we do the name of the combo box.items.add. And then we would pass whatever it is that we want to add to it. In this case, we would take the element at index I of array empNames. And then we would just keep incrementing I until we get past the end of the array. So this will, sure enough, add all the employees into the combo box. Now, we don't necessarily need to use the getUpperBound method to do that last example. We could do the exact same thing by using the length property. So here's the same code as before, except instead of using the getUpperBound method, we're going to use the length property. So we can see right here, we'll just simply do empNames.length. Now that gives us the number of elements. So if we want to get the last element, we would have to subtract that by 1. And then everything else in here remains the same as far as getting each element from empNames and then adding it to our combo box. We'll do one more example of how we would traverse through an array. And this is a pretty simple problem. Let's suppose we have an array of 10 integers. And let me ask you, how would you find the maximum element in this array? There are a couple ways to do it. Now, if you were given all 10 numbers in front of you, you can easily point out which one is the largest. You would just go, that one right there. And how would you do that? Well, you would look at all the values, and you'll see that one is the largest among all the values, so you can just pick that one. But here's the problem. A computer can't do that. A computer can't look at all the numbers at once and just say, yep, that one right there is the largest one. A computer can only look at one number at a time. So when it's looking at the array elements, it can only see one element of the array at the time. So what we would do is we'll traverse through the array, and as we go through the array, we would keep track of the current largest number as we read each one. So the initial number is going to be the largest one because we haven't seen any of the others. So as we traverse through the array, we would check, is this larger than our current largest? If so, then make it the new current largest, and by the time we get to the end of the array, whatever is the current largest must be the largest of all the elements in the array. Let's do an example of finding the maximum value of an array. Now, instead of showing you the entire array, I'm actually going to show you this from the perspective of the computer, just to reiterate the fact that a computer can only see one element of the array at a time. Now, you may remember what the other elements are. You may even jot down on a piece of paper what the other elements are, but just to do this correctly, look at only one element at a time. All right, so let's look at the first element. So we see here that we have 12.4. Since we haven't looked at any other elements, as of right now, this is our current maximum element. So we're going to store the max as being 12.4. Now, we might see a larger value later. We might not. But right now, the computer can only tell that at this point, the largest element is 12.4. Let's look at the next element. So we see that's 8.4. And we compare it with our max and find that it's not larger than our current max, so we don't make any changes. So we know that this cannot be the largest element. So we move on to the next one. We see that we get 13.7. So we'll compare that with 12.4. We know that 13.7 is larger, so we're going to make that the new max. So let's go ahead and update it. So 12.7 is gone. We know at this point the largest element is 13.7. Once again, it may change later, it may not. So we'll look at the next element, and we see that we have 14.7. So we compare that with our max. 14.7 is larger, so we're going to make that the new max. So 13.7 goes away, and 14.7 is our new max. We'll now look at the next element. We see that we have 1.9, and we can tell pretty clearly that this is not larger than 14.7. So we can just move on to the next element. So now we'll go to 17.3, and we see that this is larger than 14.7. So we're going to make this the new max. So we will update our max variable. So now we'll move on to the next element. We see that we get 16.4, and that is smaller than 17.3. So we don't make any changes to our max. We'll move on to the next element. We have 17.7. We see that it is larger than 17.3. So that means that we'll change our max to be 17.7. So there, we made that change. We still got a couple more elements, so we're not done yet. It could still be larger. We don't know yet. We don't know what the last couple elements are, so we still have to check them. So let's go to the next element. We see that we get 4.9, and that is less than 17.7. So that means we don't make any change to our max because 4.9 is smaller. And then we get to 11.9, and we see that's less than 17.7, so we don't make any change to our max. At this point, we have gone to the end of the array. If you don't remember, we had an array of 10 integers, and this is the 10th one. So at this point, we're at the end of the array. We see that our current max is 17, so sure enough, this has to be the largest element of the array. And if you were to go back and take note of all the elements in the array, you would see that 17.7 is the maximum value.